Hello friends, welcome to VK Lectures. In this lecture, we are discussing the Karnataka Set 2020 question paper, question from 21 to 40.
Rigid body consisting of three particles A, B and C is constrained such that A and B are rigidly fixed to be at rest. Which of the following statement correctly describes the behavior of C? Actually, behavior of C means path followed. Okay. So on your right side here, A and B is fixed and C is able to move. Now first of all we want to know what is mean by a rigid body. Rigid body is such that all the particles A, B and C, their distance will not change, are fixed. A, B, the distance is fixed, and C to B fixed, and this CA is also fixed. This do not change. And what we can change is its orientation we can change, but here in this case, since A and B are fixed, the orientation of A and B should not change, or it is at fixed position. In that case, what is the behavior of C can move in a surface of sphere. No, what is the movement of C can have? It cannot move here. It can move only we can rotate this, right? When you rotate, the C will follow this path, a circular path. So C can move in the circumference of a circle of constant radius with the line joining AB passing normally through the center. See, line joining AB is passing normally through the center. This is the correct option.
Here we have a straightforward question. If a motion of the planet of mass m around the sun with the mass capital M is treated as a two-body problem, then if the t is the time period of revolution and a is the semi-major axis and g the gravitation constant, then exact form of the third law of Kepler. The answer is t square by a cube equal to 4 pi square by g into m plus m. And here with if you have pi square here, this is the simplified form. Okay, this is the simplified form, and option C is the when you are considering the two body problem.
The eigenfrequencies of small oscillation of a system having Lagrangian m by 2 into x dot square plus y dot square minus m by 2 into omega 1 square x square omega 2 square y square. So this is oscillation in two dimension. So let us write what is Lagrangian L. My Lagrangian, this first term is nothing but the kinetic energy term, the second term is potential energy term. So m by 2, if you take it out, and this is, what is that, kinetic energy. This is x dot y dot y dot. In that case, this x dot square, so x dot, so this is x dot square, and there is no x dot y dot term, so this is 0. Similarly, x dot y dot term is 0, and y double dot, sorry, y dot square, that is 1. So this is the equivalent matrix for kinetic energy term. Similarly, we can write it for potential energy term. So m by 2 omega 1, so this is x y. So here you have 1, again here 0 1. Now determinant of v minus omega square t is equal to 0. This will give you eigenfrequencies of the system. V minus omega square t, determinant of V minus omega square t. Now here, this is your V, this is your t. So V minus, so omega square, sorry, here what we left is omega 1 square. This is omega 1 square, this is omega 2 squared. Okay, so omega 1 squared minus omega square t, omega square t is nothing but, here you have only one, so the second quantity, second entry is 0, third entry is again 0, and third one omega 2 square minus omega square, m by 2 outside. Right, now determinant equal to 0 means omega 1 square minus omega square into omega 2 square minus omega square must be equal to 0, which means either this should be equal to 0 or this should be equal to 0. So let us take the first one equal to 0. So the solution will be omega square equal to omega 1 square, which means omega equal to, that means omega x equal to omega 1, omega square along y is equal to omega 2 square equal to omega y is equal to omega 2. So this is it. So what is the answer? Omega x equal to omega 1, omega y equal to omega 2. So option A. So things to remember here is, one is how to find out the eigenfrequencies and how to convert this matrix form. This is the Lagrangian, this is the matrix form for kinetic energy and potential energy. Two masses of value m are moving towards each other with equal speeds of value 0.6 c. So here you have mass m moving with 0.6 c, and on the other side you have the same mass m, not the same mass, similar mass m moving with 0.6 c. Okay, they are colliding and they are sticking together and then moving. Okay, now what is the final mass m? Now let us see what is the mass of this m dash when it is moving with point c. So the mass m dash will be is equal to gamma times m. Right, now what is gamma? We don't know, but we are given v is equal to 0.6. now write it in the form of fractions. So 6 by 10 is the value. Now write this, we have seen this shortcut how to find out gamma from v. So write it as 10, that is denominator as the hypotenuse, one side as the one side as 6, then the other side would be 8, then gamma is nothing but hypotenuse divided by side 2. This is side 1, this is side 2. So side 2 hypotenuse is 10, side 2 is 8, so 5 by 4 is your gamma. So first mass m will increase by, so m dash is equal to 5 by 4 times m. Okay, similarly this is also moving with the same speed, so capital M would be is equal to 2 times gamma m, that is nothing but 2 into gamma is 5 by 4 into m, that is nothing but 10 divided by 4 m, that is nothing but 5 m by 2. It would be definitely greater than 2 times the mass. So it will be definitely. So all values are greater. So you don't have any other option. In some questions, if you get some idea, if suppose these options were less than 2m, one of, if these options, for example, if this was 3 by 4m and this is 7 by 8m, then even without looking into doing this problem, we can definitely write B, because when a body is moving, its mass is definitely greater than its rest mass. So together mass will be always greater than 2m. This is only one. Okay, so this is the actual method how to follow. Just follow the step by step, and this, please remember this trick how to get the value of gamma from V. Please don't use gamma equal to 1 divided by under root 1 minus v square by c square. You will keep doing this problem. It would take more than 2-3 minutes. Follow these simple methods, tricks to get into this answer. The charge Q is uniformly distributed in a sphere of radius r. The divergence of electric field inside the sphere. Now, what do you mean by divergence? Del dot A, where A is a vector. Now, since it is in 3 dimension, let us take r, theta and phi for our convenience. R, theta and phi. Okay. So our function is, or electric field is a function of r, theta and phi. Since it is radially varying and theta and phi are constant, our f is a function of r only. Now A is nothing but AR, that means radial component, plus theta component A theta into theta cap, plus A phi into phi cap. So this is how you can represent a vector in 3-dimensional spherical polar coordinate. Now del dot A is nothing but 1 by r square sine theta dou by dou r square sine theta into AR, that means radial component, plus dou by dou theta r sine theta into A theta, that is the second one, theta component, and dou by dou phi of r into A phi, that is phi component. Now we have already said it depends only on r, so only this much we need to take, others are 0. So del dot A is nothing but 1 by r square sine theta dou by dou r square sine theta into AR. Now sine theta we can take it outside because it is taking derivative with respect to r. We are taking with respect to r, partial derivative. So sine theta it can come out. So del dot A is nothing but 1 by r square dou by dou r square into AR. That means radial component AR. Now, inside a spherical shell, or sorry, spherical sphere, inside the sphere, electric field is given by, electric field is KQR divided by capital R. So this is the formula for electric field inside the sphere. Then just substitute this value here. We want del dot E, that means 1 by r square dou by dou r of r square into K capital Q R divided by capital R cube. So this is equal to 1 by R square. K, Q and R cube you can take it out. K, Q and R cube taken out. R square and R cube. That is partial derivative of R with of R cube. That is nothing but 3R square. So this R square and R square get cancelled. What is remaining is 3KQ by R cube. That is 3KQ by R cube. This is del dot E. So your option is B. Now one K is missing here. So what you have to remember from this question? What is del dot A in spherical polar coordinate and electric field inside? Electric field inside the spherical or sphere. Okay. Now electric field inside is this much. What is electric field on? Electric field on the sphere. It is just put small r equal to capital R, you will get KQ by R square. Okay. Given below are two vectors. Find out which of them can be magnetic field vector. The best method you can follow is del dot B is equal to 0. This is the Maxwell's equation. So del dot B is equal to 0. Find out in which whether this 1 and 2, when you take the del dot B equal to 0, then that particular vector can be a magnetic field vector B. Okay, so let us write what is del. Del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z. K cap, j cap, I cap. Okay, so del dot, let us take the first vector. So I cap into dou by dou x of I, that is nothing but 1 plus j cap. So dou by dou y, that is second derivative. It must be, sorry, first that with respect to y, z. So that is not equal to 0. So this is not equal to 0. So del dot, your first vector is not giving 0. So first vector is not a magnetic field vector. Now take the second one, del dot second one. 2x with respect to x means 2 plus yj with respect to y means 1 minus this 3 times z means again 1 k cap. So 2 plus 1 3 minus 3. So this is giving you 0. So this can be a magnetic field. So your option is 2 is true. Yeah, 2 is true and 1 is false. Suppose this was xi cap minus zk cap, then this would have been also correct. Or if it was xi cap minus zk cap, sorry, yj cap, then also your answer would have been for both of them are true. Just check del dot B. At the interface between two dielectric, normal component of electric field satisfied. So what you need is, here in this question, electric field normal component. How do they satisfy the boundary condition? What is the condition imposed on the normal component of electric field? This is what the question. Now when electromagnetic wave move from one medium to another medium, let me call this as 1 and 2. So when they move, these quantities, normal component and the transverse component, N represent normal component and T represent transverse component. This one represent the medium. Okay. What are the conditions imposed on these quantities? That is what the question is. Now the boundary condition will follow these relations. The transverse component of electric field are same, equal, and normal component of magnetic field are equal. H2T minus H1T equal to IF by A. This IF is nothing but current, free current, current by area. Now what is H? H is equal to B by mu. Okay. Now D2N minus D1N equal to Q by A. What is D? D is nothing but epsilon E, displacement vector. Now what is Q? Q is total charge and A is area. That is nothing but sigma. So when you substitute this D equal to epsilon E in a last equation, the fourth one, what you get is epsilon 2 into E2N minus epsilon 1 into E1N equal to Q by A, or you can write sigma, surface charge density. So your option is option A, the boundary condition on normal component of electric field at the interface. Okay. So please remember these boundary conditions. It is necessary, and for charge free and current free region, this quantity will be 0. Then H2T and H1T will be equal. D2N and D1N are equal. A charge Q is placed at AB, that means in the first quadrant, between two right angled triangle grounded conducting planes. Between two right angled grounded conducting planes. So this is from method of images. Method of images. That means you are assuming this in image. Okay, conducting planes. Then image charges and their locations are. Now here is a conducting plate kept along Y, and along X also there is a conducting plate kept. So this Y will also reflect, X will also reflect. From due to Y mirror on Y axis, you will get exactly a point here where that point is Y is positive. So Q A is X direction, right? So A is minus A comma B plus B, and charge minus, negatively charged. Similarly, due to X, there will be a point here that is in the fourth quadrant. So Q, fourth quadrant, Q A B. So A towards A, so that is positive, B is negative. Similarly, due to this, here also you will have a charge. So this is also minus, because first reflection minus, second reflection positive. Positive Q, it is in the third quadrant, so both are negative, minus A minus B. So look at this, only in this third quadrant it has to be plus. So third quadrant plus, only B, only one option. This also it is. Electric dipole moment of HCl molecule is 1 dB. Now that value of 1 dB is 3.3 into 10 to the power minus 30 coulomb meter. Now the electric field due to this dipole at a distance of 100 angstrom from the center of HCl molecule on the line joining H and Cl ions. Now you have H here, which is positive, and here you have Cl minus. So this is acting as a dipole. Okay, now the dipole moment is given as P. Dipole moment P equal to this much value, 1 dB. Now the question is, from this way, from the center of the line joining H and Cl ions at a distance r equal to how much, 100 angstrom, you have to find out the electric field. Now once for a dipole, once the dipole moment P is given, what is the electric field axial? Axial is 2p divided by 4 pi epsilon naught r cube. If it is equatorial electric field is just the half, p divided by 4 pi epsilon naught r cube. Now here everything is given, we just have to substitute values. So E axial equal to 2 times p value is 3.3 into 10 to the power minus 30 divided by 4 pi epsilon naught into r value is 100 angstrom whole to the power 3. Now this 1 by 4 pi epsilon naught, you can take it as unity. Then what you are getting is, here you will get 6.6 into 10 to the power minus 30 divided by 100 cube is nothing but 10 to the power 6 angstrom, 10 to the power minus 10 whole to the power 3. So 10 to the power minus 30 and 10 to the power minus 30 gets cancelled. What it is remaining is 6.6 into 10 to the power minus 6 in terms of coulomb meter square, because r square comes in the denominator, r cube. This much is the value. So which is the correct option? Option C. Leonard-Wishart potential R. So few options are there. So here you are given the potential, that is, this is scalar potential and this is vector potential. This is Leonard-Wishart potential for equations for scalar and vector potential. Now of what? It is of a moving point charge. Okay, now relativistic effect is included. In this equation, relativistic effect, but not quantum effect. Quantum effect is not included, but relativistic effect is included, because this beta s is nothing but v velocity by c, okay. Fraction of velocity, this is called fraction of velocity. Beta term is nothing but fraction of velocity at which the particle is moving. Okay, so your option is D. It is indicating scalar as well as vector potential due to moving point charge. One thing you have to remember, even though relativistic effect is included in this formula, quantum effect is not included. That is a classical approximation. Electric field associated with two electromagnetic waves are in the ratio 3:2. Then the energy transported per unit area. So energy, what is the formula? Energy is equal to epsilon naught E square by 2. This is total energy, that is due to electric field. Okay, so total energy is nothing but epsilon naught E square, only that much, no by 2. So that is total energy. This is energy due to electric field. So energy due to magnetic field is nothing but same epsilon naught T square by 2, but we will write in terms of magnetic field epsilon mu naught b square. Now what is the question? Electric field, what is the ratio of the energy transported? So it is proportional to, energy is proportional to E square, energy proportional to E square. So 3 is to 2, so 3 is to 2 whole square, so that is 9 is to 4. So your option P. So if the electric and magnetic vectors of plane electromagnetic wave are along, these are the directions of vectors, that is, let us take it as electric field vector and this will be magnetic field vector. And the question is, the propagation vector is along which direction? Now direction of propagation for electromagnetic wave, direction of propagation is along energy transfer, right? In which direction energy is transferring, in that direction electromagnetic waves will move. For example, if waves is moving in this direction, energy is in this direction, right? Now transfer of energy, take which vector gives you? That is nothing but Poynting's vector. Poynting vector. Okay, Poynting vector S is given by E cross H, where H is nothing but magnetic field intensity. So you can take E cross B because H and B are in the same direction. So E cross B, if you take, you get S, I mean the direction, not S, just the direction. Alright, now what is that? Write it as IJK, root 3 by 2, 1 by 2, 0, minus 1 by 2, root 3 by 2, 0. Now since K is 0, I and J component will be 0, right? I 0 plus J 0. Why? Because Kth component in both E and B is 0. So K cap into root 3 into root 3, that is 3 by 4, minus 1 by 2, this is minus this, so minus 1, so plus 1 by 4. So that is in the direction of K. So your answer is C. A dipole of dipole moment P is placed in an electric field E is equal to E naught x cap. Then the force experienced by the dipole. Force experienced by dipole means both this charge. Now here electric field is in this direction. Okay. Now here you have positive Q and here negative Q. Now this is what is dipole is. Now what we have to remember here is your electric field is not uniform. Okay. Now if this electric field was uniform, then your total force on this dipole will be equal to 0. If the electric field in which the dipole is kept is uniform, then total net force on this dipole will be equal to 0. But the point here is E depends on the position. Electric field depends on the position. Now this is 0. As you go along this x-axis, what happens is electric field will increase in this way, E naught x cap, E naught into value of that x coordinate, point in the x coordinate, and I cap. Now here when you come towards the negative region, that means towards the left, you have E naught minus x into I cap. So this is the electric field at this point. Okay, that means at minus q your electric field is this, and at plus q your electric field is E naught x cap. Now what is the force here? Force is equal to electric field into charge. Now what is the electric field? E naught into x into I cap, that is electric field, into q. So E naught x q I cap. I cap means it is in the positive direction, so this is the force direction. Now look at this particular charge, that is minus q. Then what is the force here? Force is equal to E naught into minus x, E naught into minus x into, what is the charge? Minus q. What is the direction? I cap direction. In the I direction. Now this is nothing but E naught x q in the direction of I. Now this is experiencing a force equal to F1, or let me write it as F minus. This is experiencing a force F plus. Okay, so F plus is in positive x direction, positive I direction. F minus is also in the positive x direction. So together net force is equal to F plus plus F minus, which is equal to E naught x cube, E naught x cube plus E naught x cube, both are in the same direction, so I. So that is equal to 2 times E naught x into q. Now 2x cube, that is nothing but dipole moment, 2x q equal to p. So what is the, there is I cap also you can write. So what is the net force? That is equal to px, that means the direction is x, that is the indication of px, into E naught into I cap. So this is the net force. So that's your answer. Before getting into this question, if there is a current carrying wire of some length, finite length, let me call this AB, and angle made by A and B to this point is alpha and beta. I want to find out the magnetic field at this point. Now that magnetic field at that point is given by B is equal to mu naught I divided by 4 pi r, the distance from the wire to that point, into sine alpha plus sine beta. Okay, so this is the formula for finding the magnetic field. Now here, if this wire is being extended to one end, that means this A end is being extended to infinity, that means this alpha is tending to 90 and beta value will be very small, so we will neglect. So if it is extending to one end, alpha value is 90, so sine alpha is 1, so your magnetic field will be equal to mu naught I by 4 pi r. Now suppose it is extending to both sides to infinity, so sine alpha also will be equal to 1, sine beta also equal to 1, so then magnetic field will be equal to mu naught I divided by 4 pi r into 2, because sine alpha plus sine beta, so that is nothing but mu naught I divided by 2 pi r. Now here the question is very similar. Here alpha is value is 45, beta value is 45, so sine alpha is 1 by root 2. So just write, let me write the magnetic field, mu naught I divided by 4 pi. What is the r, the distance r is nothing but a by 2, right? So a by 2 into sine alpha plus sine beta. Sine alpha is 1 by root 2, so 1 by root 2 plus 1 by root 2. Okay, so what is that? 2 divided by root 2. So mu naught I by 4 pi a into 2, this is going up, into 2 divided by root 2, right? Now this is for one side. How many such sides are there? 4 sides are there. So multiply by 4. So this 4 and this 4 get cancelled. Root 2 gets cancelled. So this becomes, so finally our answer is mu naught I by pi a, mu naught I divided by pi a into 2 root 2 into 2 root 2. So 2 root 2 mu naught I by, so pi is missing here. So pi, so your option is C. Energy eigenvalue of a particle of mass m confined to a one-dimensional box of length L. Now, what is the formula? It's a direct formula. Energy eigenvalue is equal to n square pi square h cross square divided by 2ml square. So your answer is C. Now for this is one-dimensional box. For two-dimensional box, nx square plus ny square into pi square h cross square divided by 2ml square. Now this is true only if your length, two dimension length lx equal to ly equal to l. Suppose if the length is not correct, same, what you have to do, nx square pi square h cross square divided by 2m lx square, that means length along x-axis, plus ny square plus ny square pi square h cross square divided by 2m ly square. For 3 dimension nz square pi square h cross square divided by 2m l square. Nx, ny and nz are the respective states. Okay. The ratio of wave numbers of first Balmer spectral line of hydrogen atom to that of the second Balmer line. So what are the lines? Lyman, Balmer, Passion, Bracken and P. That actually fund, P fund. Okay, remember it like that. Now Lyman n value 1, Balmer for 2, 3, bracket and fund for 5. So n means nf, final state. So how will you find out wave number? Wave number 1 by lambda is equal to r naught Rydberg constant into 1 by nf square minus 1 by ni square. Now about which line they are talking about? Balmer. So nf is equal to 2. So 1 by lambda r naught into 1 by 2 square minus 1 by 3 square. So this is the first Balmer series, Balmer line. Second one will be R0 into 1 by 2 square minus 1 by 4 square. So this will be second. Third one will be 1 by 2 square minus 1 by 4 square into R0. And the question is the ratio of this 1 by lambda to this one. Okay. So this is 9 minus 4, that is 5 by 36. So that is equal to 1 by 9 minus 1 by 4 minus 1 by 9, that is equal to 9 minus 4 divided by 36, that is equal to 5 by 36. Now 1 by 2 square, that is 4 minus 1 by 16, that's equal to 16 minus 4, that is equal to 12 divided by 4 into 16. Now this quantity divided by this quantity, so 5 by 36 divided by 12 divided by 4 into 16, so that's equal to 5 by 36 4 into 16 divided by 12. Okay, 6 times you can write it as 4, this is 3, right? So this again 1, this is 9, so 5 into 4, that is 20 divided by 9 into 3, that is 27. So this is the answer, but none of the answers here, it is given as hash, so answer is not given in the option. But this, if it was Lyman series of 1 and 2, first and second Lyman series, the ratio of wave number of first and second Lyman series, instead of it Balmer, if it was Lyman, you would have got this answer B. Okay, 27 by 32 you get it. It was for Lyman series for 1 and 2, but for this Balmer series for first and second line, it is 20 by 37. The probability current density for psi of r is equal to e power ikr divided by r, where k is a real constant, and this probability current density has a magnitude. So they are asking about probability current density. Now what is the formula? If psi is equal to e power ikx, then probability current density, that is J, is equal to magnitude of A whole square into h cross by m into coefficient of ix, that is k. So what we have, according to the formula, h cross k by m, what is magnitude of this A? That is nothing but 1 by r whole square. So that is equal to h cross k by m r square. So h cross k by m r square. So B is your answer. 1, 2 and 3 denote set of mutually orthogonal state. Okay, now so these are different states, mutually orthogonal. Okay, norm of the state, norm means n, value of n. Psi is given by norm of the state for psi. So a combination of 1, 2 and 3 is given. So A into 1 plus B plus IC into 2 minus I into ID into 3, the state. third state, first, second and third. So our wave function or the particle is in first state, second state and third state in this proportion: a, b plus ic and minus id. Now we know psi, this is nothing but psi star psi. Okay, psi star psi must be equal to 1. That means the coefficient of first state, that is a square, plus square of the coefficient, that means square of the coefficient of first state plus square of the coefficient of second state. What is that? B plus ic, that is nothing but b square plus c square plus d square must be equal to 1. So what is the norm then? Norm is nothing but under root a square plus b square plus c square plus d square. Now why b plus ic is whole square is b square plus c square? B plus ic into b minus ic. This is what is more multiplied, psi star psi. When you have to multiply by psi star means complex conjugate. This is complex number, this is its complex conjugate. For id also you have to take the complex conjugate. For minus id, complex conjugate is id. So minus id into id is nothing but d square. This is nothing but b square plus c square. It will be like a square minus b square, a square minus b square, right? A plus b into a minus b. So a square minus b square. What is b? So I square will come. I square is nothing but minus 1. So b square plus c square. So norm n is, that means what do you mean by norm? You have to divide while normalizing. You have to divide this quantity psi divided by this particular quantity. Then you will get psi star psi equal to 1. Just to make the probability equal to 1. So this is our commutator. Let us first simplify it as writing as a function of x, taking that x. So x cap into x comma px square plus x comma px square into x cap. So this is how we expanded. So x cap into x comma px is nothing but ih cross, and x comma px square is nothing but 2px, that is derivative of px square with respect to px, plus x cap into x cap comma px square is that is nothing but ih cross into 2px. So ih cross into 2px into x cap. Now you see this ih cross and 2 is common. Take that common out. 2i h cross into x cap into px cap plus px cap into x cap. So option C. Same way you can use this x square also. How? So x square comma px into px plus px into x square comma px, right? So x square px, that is ih cross into the derivative of x square, that is 2x cap into px cap plus px into x comma px is nothing but ih cross the derivative of x square that is 2x cap. So I h cross into 2, that is common. So 2I h cross into x cap px cap plus px cap x cap. Both way you can get the same answer. Okay, again there is more difficult methods, lengthier methods. You can consider even px square as a function of x and then, but this would be fine for you. Now, trace of a matrix alpha x, beta and alpha x, where alpha x and beta denote Dirac matrices. Now, these are sigma x, sigma y, sigma z. These are Dirac matrices. Now you see in all these matrices your trace is 0. Sum of the diagonal elements is 0. Okay. Now properties of this Dirac matrices are sigma x square is equal to, you are getting an identity matrix. Similarly, sigma x square equal to sigma y square equal to sigma z square. These all are identity matrix. Now coming to the question, alpha in x into beta. Just take any two matrices and make a product. Sigma x into sigma y. Just see 0 1 1 0 multiplied by 0 minus I 0. Okay. And what about the determinant? Determinant of Dirac matrices is equal to minus 1 for all. Determinant is equal to minus 1 and a trace equal to 0 for Dirac matrix. So 0, what, that is I, again 0, again 0, minus I. So this is one product into the same matrix sigma x, that is this matrix 0 1 1 0. So 0 1, right, 0 0, so 0 and I, then minus I, then again 0. Now what is the trace here? Again trace again here is 0. Even in this product, first product, trace is equal to 0. So your product trace of this matrix alpha x beta alpha x is 0. Option A.